to use a little bit of it in some real life situations. For example, oh boy, let's write this problem down. Bob wants to know the height of a flagpole. Bob wants to know the height of a flagpole. Now, what the problem with finding the height of a flagpole is, most people don't have a long enough ladder to get to the top. And then if you did get to the top with your long enough ladder, you'd have to have a long enough tape measure to drop down to the ground to figure out the height of it. So it's a tough thing to do. So Bob, being some sort of a mathematical kind of guy, does this. Bob stands a meter stick in a vertical position into the ground. Bob sticks a meter stick into the ground I hope it's a sunny day, Bob. Bob sticks a meter stick into the ground and finds the length of the shadow at 120 centimeters. Yikes, this is a long problem. At the same time, oh no, tell me that's not true. Yeah, at the same time, he finds the length of the flagpole's shadow to be 30 meters. 30 meters. How tall is the flagpole? How tall will the flagpole be? How tall is the pole? Ah, no. I don't write the problems, I just do it. Okay, now, obviously, children, the first thing you'd have to do is to, Lauren Daffenberry, you got to draw this as best you can. And this is the beauty of the whole thing. So the first thing we know, we stick this meter stick into the ground. Here's my meter stick. And it casts a shadow that is 120 centimeters long. Because the sun, up in the sky, shoots its rays down, and it casts a shadow because it blocks the sun for that part right there. Okay. Now let me caution you this thing here. We said this shadow was 120 centimeters. If you're working, you need to work with the same units of measurements for each little thing here. So if this is 120 centimeters, a meter is how many centimeters? 100, right? You should know that. It said it was a meter tall, which is 100 centimeters. Now the flagpole, children, the flagpole, which this is not drawn to scale because, well, I didn't leave myself enough room. The flagpole, we don't know how tall it is. That's our unknown. But we do know that it casts a shadow how long? 30 meters. Because, again, the sun's rays shoot down and leave it that sort of thing there. Now, because the sun is so far out there in the sky, you know for absolutely certain, well, these triangles are so incredibly close to being similar that it doesn't even matter because the sun is so far away. Because the shadows are going to be the same angle, which means the shadows that come down here are going to be the same angle. So you know that these two triangles are similar. Okay? And when you know they're similar, you can just do equal fractions or whatever. You could even do a ratio box if you want to. You could sit down here and do this thing. Okay? Which would be, let me make sure I write the right thing on. You've got the smaller triangle, and you got the big triangle. Okay, you've got the, what is this side called here? Let's call that the sticking up part. What is that? Vertical and the horizontal. They're going to be proportional. 100 over the 120 on the small is going to be proportional to, you don't know this side, you don't know the vertical position here, but you do know that the horizontal position is 30. You don't have to make this centimeters. As long as these two are in meters and these two are in centimeters, it doesn't matter because it's like a conversion thing. It isn't going to change anything.
They don't like change.
Okay, you don't have to make this 33,000. You could, and it's not going to change your answer. But in this case here, you don't have to change because it's like doing a car. If you say 1 inch on a car equals 1 foot on a real car, 2 inches on this model car is going to equal 2 feet on the big one. It doesn't matter because it's about scale factors. It's about what times this gives you this. Okay, so you don't have to, but these two have to be, and these two will be. These have to be the same, these have to be the same, but this and this don't necessarily have to be the same. Okay, so there you just need to do the math there. Is there an easy way to do this, anybody? Lucas says what?
You divide 30 into 120.
Well, you need to go from what you know to what you don't know. So to go from 120 to 30, you do what? Divide by 4. So you have to divide the top by 4, which is going to give you 25. So the height of the flagpole is going to be 25 meters, based on that right there. And again, it goes down to just making similar triangles. You'll see a lot of these problems. I mean, that's a pretty common sort of thing to do there. I'm gonna stop this because